Monitoring airborne contaminants. Airborne contaminants can present a significant threat to worker health and safety. Thus, identification and quantification of these contaminants through air monitoring is an essential component of a health and safety program at a hazardous waste site. Reliable measurements of airborne contaminants are useful for the following. Number 1, selecting personal protective equipment. Number 2, delineating areas where protection is needed. Number 3, assessing the potential health effects of exposure. Number 4, determining the need for specific medical monitoring. This module describes the factors to consider when conducting air monitoring at a hazardous waste site. It presents strategies for assessing airborne contamination at hazardous waste sites and describes instruments and methods for measuring exposures. Measuring instruments. The purpose of air monitoring is to identify and quantify airborne contaminants in order to determine the level of worker protection needed. Two principal approaches are available for identifying and/or quantifying airborne contaminants. First of all, the on-site use of direct reading instruments, and secondly, laboratory analysis of air samples obtained by gas sampling bag, filter, sorbent, or wet contaminant collection methods. Direct reading instruments. Direct reading instruments were developed as early warning devices for use in industrial settings where a leak or an accident could release a high concentration of a known chemical into the ambient atmosphere. Today, some direct reading instruments can detect contaminants in concentrations down to 1 part contaminant per million parts of air, or ppm, although quantitative data are difficult to obtain when multiple contaminants are present. Unlike air sampling devices, which are used to collect samples for subsequent analysis in a laboratory, direct reading instruments provide information at the time of sampling, enabling rapid decision-making. Direct reading instruments may be used to rapidly detect flammable or explosive atmospheres, oxygen deficiency, certain gas and vapors, ionizing radiation. They are the primary tools of initial site characterization. The information provided by direct reading instruments can be used to institute appropriate protective measures, such as personal protective equipment or evacuation, to determine the most appropriate equipment for further monitoring, and to develop optimum sampling and analytical protocols. All direct reading instruments have inherent constraints in their ability to detect hazards. They usually detect and/or measure only specific classes of chemicals. Generally, they're not designed to measure and/or detect airborne concentrations below 1 part per million, and many of the direct reading instruments that have been designed to detect one particular substance also detect other substances, which is an interference, and consequently may give false readings. Some of these devices may not detect some particularly toxic agents, including hydrogen cyanide or hydrogen sulfide. Thus, these devices must be supplemented with other methods of detection. Site monitoring. Priorities for air monitoring should be based on the information gathered during the initial site characterization. This information serves as the basis for selecting the appropriate monitoring equipment and personal protective equipment, or PPE, to use when conducting site monitoring. Depending on site conditions and project goals, 4 categories of site monitoring may be necessary. Monitoring for IDLH and other dangerous conditions, general on-site monitoring, perimeter monitoring, and periodic monitoring. Monitoring for IDLH and other dangerous conditions. As a first step, air monitoring should be conducted to identify any IDLH and other dangerous conditions, such as flammable or explosive atmospheres, oxygen-deficient environments, and highly toxic levels of airborne contaminants. Direct reading monitoring instruments will normally include combustible gas indicators, oxygen meters, colorimetric indicator tubes, and organic vapor monitors. Other monitoring instruments may be necessary based on the initial site characterization. Monitoring personnel should be aware that conditions can suddenly change from non-hazardous to hazardous. Acutely hazardous concentrations of chemicals may persist in confined and low-lying spaces for long periods of time. Look for any natural or artificial barriers, such as hills, tall buildings, or tanks, behind which air may be still, allowing concentrations to build up. Examine any confined spaces, such as cargo holds, mine shafts, silos, storage tanks, boxcars, buildings, bulk tanks, and dumps where chemical exposures capable of causing acute health effects are likely to accumulate. Low-lying areas such as hollows and trenches are also suspect. Monitor these spaces for IDLH and other dangerous conditions. General on-site monitoring. Air sampling should be conducted using a variety of media to identify the major classes of airborne contaminants and their concentrations. The following sampling patterns can be used as a guideline. First, after visually identifying the sources of possible generation, collect air samples downwind from the designated source along the axis of the wind direction. Work upwind until reaching or getting as close as possible to the source. Level B protection should be worn during this initial sampling. Levels of protection for subsequent sampling should be based upon the results obtained and the potential for an unexpected release of chemicals. Perimeter monitoring. Fixed location monitoring at the fence line or perimeter where personal protective equipment is no longer required measures contaminant migration away from the site and enables the site safety officer to evaluate the integrity of the site's clean areas. Since the fixed location samples may reflect exposures either upwind or downwind from the site, wind speed and direction data are needed to interpret the sample results. Periodic monitoring. Site conditions, and thus atmospheric chemical conditions, may change following the initial characterization. For this reason, monitoring should be repeated periodically, especially when work begins on a different portion of the site. Different contaminants are being handled. A markedly different type of operation is initiated, such as barrel openings, as opposed to exploratory well drilling. Workers are handling leaking drums or working with obvious liquid contamination, such as a spill or lagoon. Personal monitoring. The selective monitoring of high-risk workers, such as those who are closest to the source of contaminant generation, is highly recommended. This approach is based on the rationale that the chance of significant exposure varies in direct proportion to the distance from the source. If workers closest to the source are not significantly exposed, then all other workers are, presumably, also not significantly exposed and probably do not need to be monitored. Since occupational exposures are linked closely with active material handling, personal air sampling should not be necessary until site mitigation has begun. Personal monitoring samples should be collected in the breathing zone, and if workers are wearing respiratory protective equipment, outside the face piece. Personal monitoring may require the use of a variety of sampling media. Unfortunately, single workers cannot carry multiple sampling media because of the added strain and because it's not usually possible to draw air through the different sampling media using a single portable battery-operated pump. Consequently, several days may be required to measure the exposure of a specific individual using each of the media. Alternatively, if workers are in teams, a different monitoring device can be assigned to each team member. Variables of hazardous waste site exposure. Complex, multi-substance environments, such as those associated with hazardous waste sites, pose significant challenges to accurately and safely assessing airborne contaminants. These factors must be considered when developing an air monitoring program and when analyzing data. Air monitoring should be conducted by trained persons familiar with the monitoring equipment and potential hazards.